Hi, I'm Shyamala, working as Assistant Professor of Mathematics in Nala Narasimha Reddy Education Society's group of institutions. In this video, I'm going to discuss on problem on diagonalization of a matrix. So the question is, diagonalize the matrix A and hence find A power 4. To diagonalize a matrix A, first we need to find eigenvalues. To find eigenvalues, we need to take the characteristic equation determinant of A minus lambda I equal to 0. Determinant of A minus lambda I, we have discussed previously how to write A minus lambda I. The matrix A will become as A minus lambda I is just nothing but the changes only will be in the diagonal elements of A. 1 minus lambda, 2 minus lambda, 3 minus lambda. Remaining all elements remain the same. Now we will find the determinant of this matrix. So first take the first element 1 minus lambda into 2 minus lambda into 3 minus lambda cross multiplication minus 0 into 0, 0. Next go to the second element minus 6 into minus we have to put, then take the second element 6 into 1 into 3 minus lambda minus 0. Next, last element plus 1 into 1 into 0, 0 minus 0 into 2 minus lambda 0. So we have 0 for the third element. Now go to this next step. Just this is 1 minus lambda, 2 minus lambda, 3 minus lambda minus 6 into 3 minus lambda. Remaining are 0 equal to 0. Now in these two elements we have 3 minus lambda is common. So take out 3 minus lambda. Then we will have 1 minus lambda into 2 minus lambda from the first term minus 6 from the second term. Next we will multiply these two terms. 1 into 2, 2 minus lambda into minus lambda plus lambda square minus 2 lambda minus lambda minus 3 lambda, and this minus 6 I have written here. 3 minus lambda is as it is. Now lambda square minus 3 lambda minus 4 equal to 0 is the next simplification. And then we will find the we will factorize this one. So lambda square minus 4 lambda plus lambda minus 4 equal to 0. 3 minus lambda into, in this equation let us take lambda common. Then we have lambda minus 4 plus lambda minus 4 we have. Now 3 minus lambda. Lambda minus 4 is common in these two terms. Then we will have lambda plus 1. So the eigenvalues are lambda equal to minus 1, 3 and 4. These are the eigenvalues. Now we will find the eigenvectors corresponding to these three eigenvalues. Now let us consider, let us find eigenvector corresponding to lambda equal to 3. To find eigenvector, we have to take a minus lambda I into x equal to 0. So that we have taken by the definition. A minus lambda I we have written in the previous page that I have copied, and x is the eigenvector which with the unknowns x, y, z. Next, lambda equal to 3 we have to substitute here. Then 1 minus 3 becomes minus 2, 6, 1. Then 1, 2 minus 3 becomes minus 1, 0. Next 0, 0, 3 minus lambda. Okay. Next, applying row operations on this R2, and we will make this 1 as 0. So on R2, what we do apply is 2, we will multiply this R2 with 2 and then add it to R1, then this 1 will become 0. So minus 2, 6, 1, first row will be as it is. In the second row, 2 1 ja 2, minus 2, 0, minus 2 plus 6 is plus 4, and then 2 into 0, 0 plus R1 is 1. So we have this one. Last row is anyway 0. So this is the echelon form. Now we will write equations. This matrix we will write into equations. That equations are minus 2x plus 6 into y, 1 into z equal to 0. Next, 4 into y plus z equal to 0 is the second equation. Now we have two equations with three unknowns. So we will consider one element as z. So that we can, one element as k. So let us take y as k and substitute here. Then we will have z equal to minus 4y, that means minus 4k. Next, substituting this in the first equation means y and z values if we substitute here, then we have minus 2x plus 6k, and z value is minus 4k. and all of them if we substitute, we get x value as k. So we got xyz values that we are substituting in the first eigenvector kx1, k and minus 4k. So if we take out k, we have 1, 1 minus 4. So when we are using this eigenvector, we will take k equal to 1 and we will use just only 1, 1 minus 4. Now we will find eigenvector corresponding to lambda equal to 4. Again consider a minus lambda into x equal to 0. Write that matrix again. Then lambda equal to 4 if we substitute here, then 1 minus 4 becomes minus 3, 2 minus 4 becomes minus 2, 3 minus 4 becomes minus 1. Remaining all are same. Now we perform row operations on R2 and make this element as 0. So which operation it is? 3R2 plus R1. So multiplying R2 with 3 and add it to R1, then 3 1 3 minus 3 is 0. 3 2 minus 6 plus 6 is 0. 3 zeros are 0 plus 1 is 1. And the third row remains as it is. Now on R3 we perform another row operation, that R3 we will add to R2. Then we have the last row becomes 0. Now let us write this into equations, because this is in echelon form. We need not perform any other row operations. Now we will write this into equations. Then what we have, minus 3x plus 6y and plus z equal to 0 is a one equation. Another one, 1 into z equal to 0. So we got z equal to 0. So we have only two variables to find out. One equation with two variables means we should consider one element as k. So let us take y as k and substitute in this equation. Z value 0, y value k. If we substitute here, then we get x value minus 3x plus minus equal to minus 6k we have, and x equal to 2k. Let us substitute all these into x2. Then we have x value 2k, y value k, z value 0. Take out k, then we have 2, 1, 0. And we will consider k equal to 1 when we are going to use x2. Now we will find the eigenvector corresponding to lambda equal to minus 1. Consider a minus lambda I into x equal to 0. And this is the matrix. In this lambda equal to minus 1 we have to substitute. Then first element will be 2. Then second element 2 plus 1 3, third element 3 plus 1 4. Again we perform row operations on R2, and that is the 2R2 minus R1. So 2 1 2 minus 2 0, 2 3 6 minus 3 6 0, and 2 zeros are 0 minus 1 minus 1. Next last row remains as it is, because now we are not performing any row operations. Now in the next step we perform on R3. R3 is R3 plus 4 R2. So on R3, if we perform row operation, first and second rows will be as it is. On the third row, 4, and this R2 we are multiplying with 4 and add it to R3. Then we have this element as 0. So now let us write it into equations. One equation is 2x plus 6y plus z equal to 0. Another equation, minus z equal to 0. That means z equal to 0. So now again we will take y or x as k. So now we are taking y as k and substitute in the first equation. Z value 0, y value k. If we substitute, we have 2x equal to minus 6k, x equal to minus 3k. So now the third eigenvector is minus 3k, k 0. So take out k, then we have minus 3, 1, 0. This is the third eigenvector. Now these are the eigenvectors, x1, x2, x3. These are corresponding to 3, 4 and minus 1. Now we have to write the matrix P by using this eigenvectors. So P is the matrix which contains its columns as the eigenvectors x1, x2, x3 that we have written here. This is x1, x2, x3. Now we have to find out P inverse. To find out P inverse, of course in engineering mathematics you can use calculators to find out P inverse. Also I show you how to find the P inverse by using the normal method. That is actually P inverse formula is 1 by determinant of P into adjoint of P. So I find first determinant of P. So to find the determinant of P, let us take first element 1 into 0 minus 0 into 1 0. Now take the second element minus 2 into 1 into 0 0 minus 1 into minus 4 minus 4. So it will become plus 4. Then here it is minus 3. So minus 3 into 1 into 0 0 plus 4. That is what we got, and which is minus 8 and minus 12. which is nothing but minus 20. So why we have find first determinant of P means if we have determinant of P non-zero, then only we can find P inverse. That is why we have find the determinant of P. Now we will find adjoint of P. To find adjoint of P, we need minors and their cofactors of all elements of the matrix P. So I show you how to find the minors and cofactors of all elements of P. So first minor I denote with Mij and cofactor I denote with the Aij. Mij means first I am finding M11, that means this is a minor of the first row, first element. Okay, so first row first element is 1 in our matrix. So to that 1 we are finding the minor. So how do we find the minor means delete that row and column in the matrix P, then we remain with this 2 by 2 matrix 1 1 0 0. Its determinant we are going to find. That determinant is nothing but minor. So that is M11. Now M12 is that is we are going to find the minor for the second element of the matrix, which is uh, delete that row and that column and that row. Then we have the 2 by 2 matrix as 1 1 minus 4 0, and its determinant is minus plus 4. Next M13 is last row element of first row we are finding, its minor, and delete that first row and last column, then we remain with 1 1 minus 4 0, and its determinant is plus 4. Again we find the minor of the second row first element, and if we delete second row and first column, then we remain with the 2 by 2 matrix 2 3 0 0. Its determinant is 0. Next M22, if we go for M22, then delete second row and second column, because we are going to find the matrix minor of this just a minute, minor of this element. That's why delete that corresponding row and column. Then we have the 2 by 2 matrix as 1 minus 3 minus 4 0. Its determinant is minus 12. And how we are writing cofactors of these elements is first element we will take plus sign only. So whatever we have to that we write as it is. To the second element we take minus, then alternate plus minus we take. Actually the formula is minus 1 whole power I plus j into mij, that is a cofactor of aij. So if we use that formula, what will happen is, for the first element always we will have positive. For the second element a negative value we have to take. To this positive value only, to this negative value we have to take, then again positive, then negative, like that we will have. That is why a11 is as it is. So that is why this is 0 and this is also 0. A12 to when coming to A12, since M12 is 4 and its negative value we will take, that is why A12 is minus 4. Now again A13, M13 is 4 and A13 also we will take 4 only, because we take the positive. Of course M21 is 0, so negative of 0, nothing but 0 only. So we keep as it is. Next M22 is minus 12 and minus 12 only we take here also. Now while finding other minors also we will find the same in the same manner. M23 means it is second row third column, that's why we will delete second row and third column. Then we will have this 2 by 2 matrix and its determinant is 8, and its cofactor is, previously we have taken positive value, that's why negative of this value we have to take. So we have A23 as minus 8. Now M31, that means third row first column, third row first column if we delete, then we will have this 2 by 2 matrix, and its determinant is 5, and its cofactor is because here we have taken negative, it will be positive only, so 5 remains same here also. Next M32, that means third row second column if we delete, then we will have this 2 by 2 matrix and its determinant is 4, and here we have taken positive, that's why we have to take negative value here. Next M33 if we take, then last row last column if we delete, then we will remain with this 2 by 2 matrix and its determinant is minus 1, and its cofactor is same thing, minus 1 only we have. Now we are writing the cofactor matrix of P, that means A11, A12, A13. A21, A22, A23, A31, A32, A33. Like this, we have written the cofactor matrix of P. Now we will write adjoint of P. Adjoint of P means transpose of the cofactor matrix. Adjoint of P means transpose of the cofactor matrix. That is why transpose means this row we will write into column. This cofactor element, cofactor matrix first row will become as first column here. Second row will become as second column. Third row becomes as third column. This is a adjoint of P. Now we will go for P inverse. P inverse means 1 by determinant of P into adjoint of P. 1 by determinant of P we got minus 20, and then adjoint of P is this matrix. And this minus I am taking inside, that means multiplying all these elements with minus. So this matrix will become as 1 by 20 into 0, 0 plus 5 becomes minus 5, and second row all elements here are minus terms, so it will become plus, and then third row minus 4 and then 8 and then 1. This is a P inverse matrix. Now we will go for P inverse A into P. So first I am writing P inverse matrix and then the matrix A and then the matrix P. Now we have to multiply these three matrices to get the diagonal matrix. So first multiply these two matrices, then we have 0 into 1 0, 0 into 1 0 and minus 5 into 0 0. Next 0 into this element 0, 0 into this element 0, minus 5 into this also 0 only. 0 into this 0, 0 into this element 0, and minus 5 into 3 minus 15, like that. Second row first column if we multiply, 4 1 ja 4 plus 12 1 ja 12, that is 16. Next, just a minute. Next, second row, second column, if we multiply, we get 48. Second row, third column, if we multiply, 16. Next, third row, first column, if we multiply, we get minus 4 into 1 minus 4 plus 8. That means plus 4 we get. And similarly, second row, the last row, second column, last row, third column gives us minus 8 and minus 1. And this matrix we will keep as it is. Okay, now we will multiply the last two matrices, and 0 into 0 0, 0 into 0 0, minus 4, 15 into minus 4 is 60, and then 0 into 2 0, 0 into 1 0, minus 15 into 0 also 0. Next, 0 into minus 3 0, 0 into 1 0, and then minus 15 into 0 0. So that is the first row. Now coming to second row, 16 1 ja 16 plus 48 minus 64 gives us 0. 16 2 is 32 plus 48 into 148 plus 16 zeros is 0 gives us 80. Next, second row last column is minus 48 plus 48 0, 16 zeros are 0. So third element is 0. Now coming to the last row, 4 1 ja 4 minus 8 plus 4 is 0. 4 2 ja 8 minus 8 0, minus 1 0 is a 0. Next 4 3 ja minus 12 minus 8 minus 20. So that is what we got. Now divide these three elements with 20. Then we get 3 0 0 0 4 0 0 0 minus 1. This is the diagonal matrix D. So in the matrix P, how we have written x1, x2, x3. x1 is the eigenvector corresponding to lambda equal to 3. x2 is the eigenvector corresponding to 4. And x3 is the eigenvector corresponding to lambda equal to minus 1. So in the same order we have got in the matrix D also. So this is the diagonalization process. Now we calculate a power 4. A power 4 is P d power 4 P inverse. So let us write P d power 4 P inverse. So d power 4 means just d is a diagonal element, diagonal matrix. That is why its power to the power of 4 means only uh, taking to the power of 4 of all its diagonal elements. So d power 4 is 3 power 4, 4 power 4 minus 1 whole power 4 into P inverse we have written as it is. Now its power 4, 3 power 4 is 81, 4 power 4 is 256, minus 1 whole power 4 is plus 1. Remaining all we have written the same. Now multiply the first two matrices. 1 into 81 81, 2 zeros are 0, minus 3 zeros are 0. Like that, 1 into 0 0, 2 into 256 is 512, minus 3 into 0 0. 1 into third element, 1 0 is a 0, 2 0 is a 0, minus 3 into 1 minus 3. Like that, multiply the other rows also, and then multiplication of these two matrices gives us this one, and divide all these elements with 20, then we get a power 4 like this. So this is the process of calculating a power 4 and diagonalization.